Okay, so let's see how many people we have. Until now, we have 98. Yeah, I hope the others will join us soon. Okay, so welcome back. Good morning to everyone. And today we're going to look at probably the last topic known as roughness and roundness measurement. As I mentioned earlier, if there is a bit of time, then I will try to cover, just introduce the concept of GD and T later. So today we are going to look at roughness measurement and roundness measurement. Usually these two go together because they come under the area of surface metrology. Okay, so surface metrology itself you can divide into contact and non-contact types. So we're going to look at only contact method because the non-contact optical methods, those are outside our scope for this particular course. So we look at what are known as roughness and roundness. So you need to understand what is the concept of roughness and roundness before we go into the detail. So basically, very briefly, what you're going to look at will be instrument like this. You'll come across this a lot in industry. Whenever you are in the production department, they are making parts and so on. They want to know whether it meets the specification. Okay, so one of the basic specification you have will be the roughness of the surface. Whenever we want to make a product, what's very important will be the surface finish quality. So the cost of the product also will depend on the kind of surface finish that you specify. If you want a surface to be extremely smooth, and then probably you need to do grinding, polishing, lapping, and so on. So that will involve a lot of cost. So if we don't specify any specification of roughness, then you'll find that the product manufactured may be of low quality and the surface may not be very as smooth as what you expect. So we are going to look at the concept of roughness, how to measure roughness, what instrument to use roughness, and how do you quantify roughness. Okay, so we are not going to use the term smoothness. So smoothness and roughness more or less mean the same thing, but in technical sense, in the industry, we use the word roughness. And then you're going to look at what is the meaning of roundness and how roundness is measured. Yeah, so this year I'm not sure whether you're going to do a lab on roundness. Maybe I'm not very sure. If you're going to come here half a semester, maybe you'll be doing an experiment on roundness. Otherwise, you'll be doing this during your third year. So basically, we're going to look at this kind of instrument. Now, why roughness is important? There are many products like this. You can see a crankshaft here. Okay, there are many parts which are touching each other, they are rubbing each other and so on. And so whenever you have products where surfaces are in contact, and then you find that the surface finish quality is extremely important. Okay? So we need to quantify what is that value. If you take a ruler, if you draw a line, okay, you draw a line, you take a ruler, you measure, the line is 5 cm or 10 cm long. So you can quantify length. Okay, length is a variable that you can easily quantify. So if you are given a surface of different roughness, how do you quantify? Which is smoother, which is rougher, and so on. Okay. Now the other aspect we're going to emphasize in this particular topic will be roundness. Okay, there are many machine products where roundness is extremely important because these products are spinning at very high speed. Like your certain shafts in your car engine, for example, the transmission system, for example, they are rotating at very high speed. Okay, so you want the surface to be as round as possible. Okay, any error in roundness will cause vibration. Vibration will be transferred to the bearings. The bearings will fail very easily, very quickly. So we're going to look at this basically. Okay, so if you look at a cast like this, and so probably inside here, inside this hole, roughness is very important. And this picture actually shows one type of roughness tester known as a portable roughness tester. So this kind of roughness tester, you can bring it to the product. So this product is so huge, you can't really bring it to the lab or put it on a surface for measurement. So we bring the instrument to the product. And so we put the instrument here. So what you notice is that this instrument has a probe. As a probe at the end here, you have a small stylus that is tracked along the surface. And the stylus will move along the surface through a pre-specified distance, and then the measurement is displayed here. You can see the profile here, and the blue color graph here. This shows the profile of the surface, and then the measurement results are displayed here. Depending on what you want to select. In this particular case, they have RSM, RZ, and so on. So we are going to look at some of these parameters, and not all, but some of these parameters, to understand what are the basic methods of quantifying roughness values, how to make sense of all these dimensions and so on. So we're going to look at this. And before that, I'll show you a very short a video clip. This is a this is a contact type of roughness tester, a portable roughness tester. So you just have to place it onto the component. Okay, and then press the start button. You can see the stylus moving. So this is known as skidded type of stylus. And later I will explain what are skidded and skidless type of stylus. Okay, you can see here. I just pause this video. I want to pause this video. Okay, you can see somewhere here. Okay, the measurement is being done. You can see the movement of the stylus. You can see the graph. So this is actually a plot of the profile. You can see this graph here. This is a plot of the surface profile. This particular surface, this guy is measuring the surface. You can see the profile there. Now what I want you all to take a look at is, look at this data inside this display here. You have this standard, ISO standard 1997. Remember this standard. Okay, so the measurement is compatible with this standard. Okay, and then look at this value here. You have lambda c. Okay, so take note of this. Later you need to know what is the meaning of this symbol here, lambda c. What is the significance of this value? Okay, and also you can see here times 5, x5. Actually it's times 5. You need to know why is it times 5. Okay, and this is the travel speed. Travel speed of this small little stylus. So it's moving there. Okay, so later we'll come back to this kind of information. So once the measurement is done, okay, the results will be displayed. I think it is not shown here. And the results will be displayed on the screen. So you can see the value of roughness value. Okay, so we'll go into the detail of this topic. So here, so what are the learning outcomes of this particular chapter? So in this chapter there are two components. One is roundness and roughness measurement. So these are the learning outcomes. You will be able to explain the difference between roughness, waviness, and form. These are very fundamental. Okay, I want you to remember this. And don't just leave the information in your mobile phone or somewhere. And try to remember what is the difference between roughness, waviness, and form. Okay, and define various roughness parameters. So I'm going to introduce a few what we call amplitude parameters. You need to know how to define them. Okay, for example, average roughness. Okay, when someone asks you what is average roughness, you don't immediately take out your mobile phone to go and check. But then you must be able to explain what is the meaning of average roughness, root mean square roughness, peak to valley roughness, maximum to minimum height roughness, and so on. And then you should be able to calculate. I'll give you a small activity. If you are given a trace, okay, a trace is a graph, a line drawing, drawn taken from the profile. If you are given a trace, you should be able to calculate the roughness value, roughness parameter, roughness value from the trace. So the last part that you're going to learn will be how to define roundness and how to determine roundness error from a trace. Again, you'll be given a trace. You are asked to find what is a roundness value. So this is a summary of overall what you're going to learn within this topic. You will learn about the difference between form, waviness, and roughness. Okay, and then you will learn what's the definition of sampling length. What's the meaning of sampling length or cutoff? Cutoff and sampling length, that they mean the same thing. And then how is it different from evaluation length? So you will learn about that as well. And then here I'm going to introduce a few roughness parameters. You will learn a few uh, basic amplitude roughness parameters, which commonly you will come across in the industry. And then how measurement of roughness is done. Okay, so you'll be looking at how roughness measurement is done, and then you'll be able to explain difference between skidded and skidless type of roughness tester. And these are the two main types of roughness tester. Yeah, most the roughness tester you saw in the video just now, those are all skidded. Okay, there are also skidless. So you need to know when to choose which. Yeah, so this part deals with roughness measurement, and then the last part deals with roundness measurement. Okay, what's the definition of roundness, and how do you measure roundness, and what is the meaning of eccentricity, concentricity, run out, and so on, and what's the practical significance of all this? Okay, so there are a lot of things to study within this one topic. Now the question is, why do you need to measure roughness? Why roughness is important? Okay. Now roughness actually quantify the surface characteristic. It tells us about the surface. Okay. I'll just give you two examples here. Now look at this example here. Can somebody tell me what is this? Okay, if you take a look, it's a brake pad. Very good. It's a brake pad. And what about this? I think you all know this. What is this? Anyone? What is this? Engine. Engine cylinder. Okay, cylinder. Okay. If you look at a brake pad, and the purpose of brake pad is to provide friction. You must be able to stop the vehicle. It must be able to provide friction. So the engineer who designs this surface designs this in such a way that you have peaks coming up like this. Okay, so the surface is designed in such a way it can provide friction. But then when you look at a surface inside a cylinder bore like this, if you look at the profile along here, this red color line is just a line, and then this profile represents this section. Similarly, here you have a line, and then this profile represents, and the profile, when you amplify, you zoom in, and then you see this. Now when you look at the surface inside here, it's very strange, and the detail, the microscopic view looks a bit strange in the sense that the top part looks flat and the upper part looks flat. So it means that this has been ground, lapped, polished, and so that it's flat. But then inside there, in between the flat areas, you have something like pits, something like valleys. Okay, why the designer make this product like this? Because he wants this section here to retain the oil. Okay, so when you have piston moving at high speed, it is desirable to have some oil retained inside here in order to reduce friction. So it's designed in such a way. So this product is designed in such a way. So the surface, when you measure the surface roughness, after some time of use, for example, after this brake pad has been used for some time, you'll find that the top section will all be worn out, and this part will become flattened. This also will become flattened. The longer you use, the more this part will be flattened. When this part becomes flattened, the peak to valley height, and that is one simplest measure of roughness will be maximum to minimum peak to valley height. So when this brake pad is worn, the peak to valley height will decrease. Okay, so if you measure the peak to valley height, if that decreases, then we know that it is time to change the brake pad. A very simple measure. Why? Because we know that if this if the peak to valley height decreases, then this surface cannot provide sufficient friction. Okay. Now what will happen if we design it in the reverse manner? Let's say we have another engineer who's always absent from class. He designs a brake pad like this. Okay, a brake pad is like this, and then he designs this engine like this. What will happen? Anybody? Leaking? The brake will skip. Very good. If you design a brake like this, it's very difficult to stop the car because your brake is on top here is very smooth. Okay, so the brake will skip. And then what will happen to the engine? Anybody? Oil leaking. You see this part is very, you got a lot of peaks like this. This is the gate inside here. Inside the bore, friction will be higher. What will happen? The friction is very high, extremely high friction. Heat. Heat will cause piston will damage. What else? What will happen? Your engine will catch fire. So imagine you have, you get jammed and so on. Friction is very high, your engine will catch fire. At the same time, when you try to stop the car, you cannot stop because you designed it like this. Okay, so this is where courses like this are very important to understand what is the concept behind roughness, why is it so important to define the characteristic of surfaces. Now, some time ago, there was a guy from a company. He asked me to do this measurement. Now, we have this in the metrology lab, in the microscopy lab. We call this Alicona Infinite Focus. And so this is a 3D metrology system. And then he gave me this kind of screw. And then he asked me to measure the roughness at the landing here. Okay, now this screw is actually made attached to to screw the hard disk drive. You can see a hard disk drive here. Okay, so the people making this hard drive, they want certain degree of smoothness or roughness on the surface. Okay, especially if there are any spikes here on the surface, that must be avoided. Okay, why? Because when we screw this into the holes inside there, if there's any part here which is rough, that small component that can break off. If it breaks off, that small particle that breaks off can go into the hard drive and it can damage the hard drive. So they want certain degree of roughness here. So this measurement was done using optical method. So this is an optical method. So when you look at a small landing over here, for example, very small area, this is what you will see. Okay, and then we can measure what is the peak to valley height, what is the average height, and all the other parameters. And you can even get a 3D view of the profile. So this is where roughness is extremely important. Okay, now we go into the technical detail. What is surface metrology compared to what you have learned earlier? All the previous measurement you have done, you're comparing with the standard. If you take a ruler, for example, you measure length. You are measuring the length of the unknown with a scale there. So that scale is your standard. But then when we do a measurement on a surface, known as surface metrology, so this area is basically it's a study of deviation between one point on a surface to another point on the same surface. So we look at the deviation from one point to another point. So the maximum deviation can be used as a measure of surface characteristic. It can be the roughness value. If you look at the highest point and lowest point within the same profile, within the same surface, that can be the roughness value. So here we're not comparing with another standard, but we are comparing the height from one profile, one point to another point. Of course, the instrument you're using must be calibrated to give you the correct height value. But comparison is between one point to another point. And the surface roughness of a manufactured pipe, we know that all the components that we have, they're all manufactured, man-made. Somehow they're manufactured. And the surface roughness will depend on the process used to make the pipe. Okay, many of you are manufacturing people, even mechanical engineers have studied manufacturing in first year. You have come across many manufacturing processes. Okay, now I want you to list all the manufacturing processes that you know until today. Okay, without looking at your mobile phone, without looking at anything, just out of your head. List all the processes that you know. Please type there in the chat group. Yeah, I'll just open up the chat. Milling. So you got milling, you got grinding. You'll come across stamping, yes, rolling, drilling, forming, machining. Okay, machining, milling comes under machining. Deburring, casting, very good. Casting, die casting, forging, forming, piercing, uh, drilling. You mean comes under drilling. Drilling is also a type of machining process. What else do we have? Welding. Welding is also a manufacturing process. It's a joining process. Welding is a joining process. If you want to produce very smooth surfaces, if you want to produce very smooth surfaces, what kind of process do we use? Spinning, lapping. We have lapping. Now we have processes known as lapping, polishing, honing, and so on. So you need to know the difference between all these. Only manufacturing engineers, mechanical engineers will know about the various processes. You ask a chemical engineer, electrical engineer, they wouldn't know much about this. Okay, so make sure you have an understanding of all the manufacturing processes. Now you'll find that the quality of surface finish we produce very much depends on the manufacturing process. Okay, so that is shown by this chart here, taken from a book by this guy here, David Whitehouse. This guy is actually the master, the giant in this area of surface and surface metrology. Okay, now let's take a look at this. Is a very important chart, and why it gives you an idea of what roughness value, what's the unit for the roughness, how big is the roughness value, and then how is it related to the manufacturing process. So this is a list of manufacturing processes going from super finishing, lapping, polishing, all the way down to milling, shaping, planing. Okay, most of you might be familiar with turning, grinding, maybe. Okay, so we look at this roughness value. You'll notice that the range of roughness value we obtain here, for example, 0.05 to 0.2. But what are the units? If I say 0.2, for example, the unit will be in micrometer. Okay, remember, the unit is in micrometer. And what is this 0.2? 0.2 is RA value. So remember this is RA. RA is average roughness. Later you'll see in detail what's the definition for RA. Okay. But what I want to show you here is that the different processes will produce different range of roughness value. For example, turning operation produce a roughness from the range 0.4 up to 6.3. Okay, so if you want to produce very smooth surfaces, you can go for polishing or lapping, for example. But my question is this: if you are using a turning operation, okay, we have done this turning using a normal turning lathe machine. Why is there such a big difference or range in roughness? Why does it go from 0.4 up to about 6.3? From 0.4 to 6.3 is a very big range.